Yes.
I want to first congratulate all of you for an outstanding accomplishment. It is certainly a busy time for all of us for lots of reasons, and I hope that you and your families are in good health. It's really a pleasure to be here with you today. Like Zaria said, I'm disappointed that I can't see you in person and congratulate you on this accomplishment. Because it's no small feat to get to this point and start weighing your options and figure out where you're headed. But I am really excited to get to spend a little bit of time with you all today because I think we have a really special marine biology program. I've been teaching at Roger Williams University for 15 years now, and I absolutely love my job. And I love my job because I love getting to work one-on-one with students. And we have so many different opportunities to get to meet in that kind of one-on-one opportunity. And what I'll say is our times are a little different right now. And so I'm going to tell you the story about life as usual from Roger Williams University, because that's what we know. And I'm sure you'll have questions about how things might change as we look forward in the near future. And I'm certainly hopeful that sooner rather than later, we'll be back on to that experience. But I will be delighted to share with you today some of my perspective about the department, about the outstanding colleagues that I get to work with, and the outstanding students that I get to work with as well. So, and I really mean it. I absolutely love what I do. And right now in this remote learning environment, I still love the engagement with students. And the biggest disappointment is not getting to be together in that right now. And so we need to look at other ways that we can kind of create community. But that's in the short term, and hopefully in the long term that changes. All right, I'm going to share my screen with you right now to share with you this presentation about Roger Williams University and our marine science program. And the first thing actually that I'm going to have you do, let's see if this updates real quick. As you are able, I would love for you to respond to this quick poll, right? So if you have your phone or tablet or something handy that you can text from, what you're going to do is text my last name, Wysor, W-Y-S-O-R, to that number that's shown there, 37607. That'll join you to this poll. And then you can answer this question. What is the most important to you in deciding which marine biology program is right for you? And there's 6 options. Just give me your 2 best. It won't let you answer after that. But so the options are world-class scientists, dedicated laboratories with specialized equipment, facilities, or access to field sites, hands-on learning opportunities or experiences, teaching excellence in the classroom, the laboratory, and the field, opportunities to combine your science with other passions, and study abroad while earning credit towards your major. So if I've done this right, that should start populating quickly. To access the poll, you're going to text to the number 37607. Just text my last name, capital W-Y-S-O-R. And you do that once to join, you should get a quick message back, and then thereafter you can submit your answers. Just do 1 answer at a time, and that'll limit you to just 2 answers. And I can see our poll is updating here. So I'm just going to give a minute for people to respond. While you're responding, I will just reiterate one of Zaria's points. You're welcome to use the chat function. I'll be honest, sometimes I keep up with the chat and the presentation at the same time, and sometimes I don't. So Zaria is going to help us to keep track with that. You're welcome to ask questions as we go along, and if I'll do my best to address them on the spot, and if not, we'll get them addressed at the end of the presentation as well. So feel free to jot down your questions as you wish. And
I think we do have one question. One student just asked if you could reiterate how to access the poll. I think maybe the number or something.
Yes, so you're just gonna text my last name, WYSOR, to the number 37607. So in the to field for your text, just type 37607, and then the message is gonna be my last name, WYSOR. That will allow you to join the poll, and then you can put in your responses there one at a time. All right. So it looks like a lot of you have a lot of interest in the hands-on learning experiences, is what I learned from this. And I will tell you that's a very popular choice, and it is a choice that we as faculty absolutely cherish. But I will also tell you that this was very much a loaded question, because what I hope you come to appreciate at the end of this presentation is that a Roger Williams University degree in marine biology will give you access to all 6 of these options. And that's really what your education, your college education is about, is getting access to the resources and the tools that are gonna help you to shape a career that's gonna be fulfilling and important in our society. And I'll tell you that when I say I love my job, I do. I feel very very fortunate in what I get to do with students, but I also feel like the job that we do as faculty working with students, as scientists, collaborators with other scientists around the world, with our students and so on, like we've got a big and important job to do. Because our world doesn't necessarily accept science. It doesn't accept the value that science brings to us in all kinds of different ways. And I have no doubts that you have seen the way that that is playing out right now around us in sometimes dangerous ways. So we have important jobs to do, and we need you to commit to pursuing your science interests and your curiosities to help other people sort of see the value in the sciences. It's not just about doing the science, it's about communicating it, about working with each other in productive and positive ways. And there's lots of ways to plug into that at Roger Williams University. So I'm excited to talk with you a little bit about some of the things that we offer here. I'm just trying to get my slide presentation to advance. There we go. So we have important work to do in the marine sciences. We've got lots of problems on our hands: overfishing, habitat species loss, coral bleaching, climate change, ocean acidification, food production, marine resources. The list goes on, right? There's important work to be done, and we need new generations of scientists, of marine biologists to pursue these types of opportunities. So how can we help you become part of these solutions into these issues? We are definitely dedicated to this, and we want to see you as part of this. And if you see me fumbling here a little bit, I'm trying to keep my Zoom controls away from my PowerPoint controls. So why Roger Williams University? We'll offer teaching excellence in the classroom, the lab, and in the field from active and renowned scientists. Our professors are scientists. They're active scientists. That's what they do. They do science with you. They offer experiential education in lots of different curricular pathways. We like to say that we have the opportunities and programs of a larger university, but the personal attention and community of a smaller college. So we want to help you change your world with your science. We have a real breadth of faculty expertise, from biomechanics and evolutionary ecology. Dr. Collin works on jellyfish biomechanics, looking at predator-prey interactions, uses a lot of very technical video-based techniques. We've got a virologist in Dr. Marston, whose work right now seems ever more relevant. We've got specialists in aquaculture and aquarium science, looking at important conservation issues and how to mitigate challenges of wild harvest of species in the oceans. Like, how can we grow these things in the lab so that we don't have to harvest from wild populations? We've got specialists in fisheries biology and coral ecology. And I don't know how many of you know, but there's actually a coral in Rhode Island. And our very own Dr. Sharp studies this and is using it as a model organism to understand global climate change. Really, really interesting work. In fact, before our state government right now is a proposal to identify the coral, the northern star coral, as our state coral, which is pretty fun. We also have a veterinary biologist, a veterinarian on staff who studies shellfish disease, among other things. And so it's a really, really interesting mix of faculty expertise, and that translates to lots of opportunities for you to discover your passions and explore your curiosities. We are very teaching centered and student focused. Our courses, all of our courses are taught by full-time faculty, and let me take that back. But many of our courses are taught by full-time faculty and a very committed part-time faculty. But the point is we don't have graduate student assistants, and that's not to say that graduate student assistants, which are common at many universities, are ill-prepared instructors. They are excellent. It's not our model. So our scientists are in the classroom with you, and it's one thing that we take a lot of pride in, is that you have access to the experts in the field. Our classes are very small. Average class size is 19. You'll probably have a few classes in the first year, your introductory bio course or introductory chem course, that might be huge by these standards. 36 is usually our max. Very rarely is it more than that. So our classes are small. I pride myself in knowing the names of all of my students before the end of the first week in class. And it's something that we can do. We have this very close relationship with our students because we're not, the faculty are not dilute relative to the students. So this translates to meaningful experiences for you because you can rely on your professors to know who you are, to endorse your strengths as a student, write letters of recommendation, and so on. So that's a really, really important thing that takes time to develop through your undergraduate program, but is very tenable, very easy to do at a place like Roger Williams University. So you will be in the classroom with faculty and fellow students who are active scientists. This image here shows our senior thesis presentations going back 2 years now. But these students are extraordinarily productive. We have a cohort of 14 students this year who will be presenting in an online forum in a few weeks. But these students, when they get to the point of presenting their thesis, it's often the culmination of 2 or more years of work. They get out to professional conferences around the world, internationally, nationally, as well as regionally as well. We have students that are publishing their work in professional peer-reviewed journals. Publication is the currency of sciences. If we just do good science and don't get the word out on that, it definitely doesn't serve the purpose, right? So students are engaged in these processes, the entire process, from coming up with an experiment to actually executing the project, communicating that, and then ultimately preparing that for publication. Our faculty have a very, very impressive record of scholarly productivity, over 80 publications in the last 5 years, and over the past 5 years, close to $8 million in external funding has been secured through the department. Now, what that means for you is that there's good research opportunities there. And it takes some work on the part of the student to say, hey, I'm interested in research, and establish a conversation. But the opportunities are there. And research, undergraduate research, where you're working on a project with a faculty mentor, will change the way you think about science I think it helps students to see that science is a process, and we don't start with answers. Science isn't just a discipline that is knowledge giving, but it's knowledge generating, that we work to figure out these problems, and we can engage students in this process in very meaningful ways. We have a great selection of courses to choose from, a real breadth and depth of courses. The marine biology program is sort of divvied up into these 3 different categories: the organismal ecology course, the applied sciences courses, and then our molecular based courses as well. So students, generally speaking, take at least 2 from the first one and at least 1 from the other categories there. That's something that you plan out in association with your advisor, with whom you will meet at least once every semester to get guidance on the coursework that you're going to be taking in the subsequent semester. I really enjoy that part of my job. Again, that's the one-on-one. You saw the picture at the beginning of the presentation, but that one-on-one opportunity to work with students, it's very, very fulfilling, and it's an opportunity that we get to connect students to other opportunities within the department, within the discipline as well. But that's you will be working with other scientists in your academic advising. We offer experiential hands-on learning in the classroom. As you can see here, the image on the left is actually an oceanography lecture. There's demonstration activities done in class. There's a herpetology class, that's the study of reptiles, is shown in the center image there. And then some modeling exercises that are being done in the image on the right there. So we try to get students to be practicing their skills both in the classroom and then also in the teaching lab. Here's a couple of images from our marine vertebrate zoology class here, doing dissections on, I'm not sure what it is on the left. On the right, it's a spiny dogfish. But we also work hard to get students out into the field as well. So these are several images that are from an ichthyology course that runs in the spring. And one of our professors there in the upper left-hand column, he's the guy in the deep water there pulling that seine net around. They're shown doing some electrofishing in the middle, and some training, some trawling aboard our 32-foot research vessel, which is a relatively new acquisition to the department. So good opportunities to get in the field. For my part, I'm a marine phycologist, so I study seaweeds or algae. I make it a habit to get out in the field with my classes 3 or 4 times. So that's about a third of the classes. We're actually in the field snorkeling when it's possible in the fall and the spring. That's definitely the harder sell. Though I did get in the water once this year in 39 degrees, and it was chilly but worthwhile. And I'll just add here that our instructors are now offering their excellent hands-on opportunities as best they can from their homes. So here's just a selection of my esteemed colleagues. It's me on the left there. I'm teaching my seaweed biology class from my basement, where I'm delivering this presentation from. And my colleagues, Dr. Taylor, who's our ichthyologist, and I teach a neotropical marine biology course with Dr. Taylor down in Panama, and then Dr. Webb, who's our marine mammologist, teaching from his home. The box, the W.B. Mason box on the right-hand side, that's got baleen sticking out of it. And I'm not exactly sure what everything else is in there, but I have never been so impressed with the dedication of my colleagues than I am right now. I've never doubted their dedication. You can be sure of that. But it is a great space to be teaching from. And right now, I would say there is a shared mission to bring our current semester to a fruitful conclusion. And I think that down the road, we're going to have learned an awful lot that makes all of us better at what we do, whether it's in the field, in the lab, in the classroom, or right now from our homes. I like to call my basement the phycology studio now. So as I said before, we have some really interesting aquaculture and aquarium science programs that you can double major in. That is a program that is designed as a double major. So you could actually take aquaculture and aquarium science along with any other major at the university. All of our graduates to date have taken it as a pairing with marine biology. But we wanted to ensure that students would get great breadth in their program. We thought that aquaculture by itself might be a little narrow. So there's lots of innovative ways you can pair that, but you cannot take a primary major as an only major in this AQS program. I see some questions coming up in the chat. Can you, I saw one, can you double major with marine biology and another subject? We commonly have students that will double major in marine bio and chemistry or math. There's a maybe 10, well, I think about 15% of our students do double major. A lot of them are double majoring in chemistry and math, where there's a fair amount of course overlap between the Bachelor's of Science option and marine biology in terms of those chemistry and math requirements. But other students will double major in foreign languages or psychology. So there's good opportunities to do that. Statistically speaking, at the university, about 80% of our students have more than just a single major. Now, I don't mean that they're double majoring, but I mean that they are getting a minor or multiple minors or certificate. So something else beyond just the major in there. So that's very, very common. As far as marine biologists, double majoring in 10 to 15%. Acceptance rate to vet schools from Roger Williams. I apologize, I don't have good numbers on that. I think one of the things that's very helpful for the students that I know who have gone on to veterinary school is that they have taken advantage of research opportunities, either with our veterinarian, who's one of our professors, or just engaged at a deep level in research. So the research experience is really important. Again, I think it changes the way you think about science, and that those critical thinking skills often translate to other opportunities, and I think ultimately more successful applications to very competitive programs like vet school. When do students typically start classes out in the field and get hands-on? So marine biology students now are entering the first science class they're going to take at Roger Williams University is an oceanography, a laboratory-based oceanography class. We used to have this as a second-year course, and in the past year, we changed it to make it a first-year course because we didn't want students, we wanted students to be able to take advantage of our unique location on the shores of Mount Hope Bay. Your natural laboratory is literally 100 feet from your teaching spaces and from the dormitories. Our research vessel is not docked at the university, but it can pull right up. Students can get on the boat right there, and they can head out into the field and start doing water column profiling, looking at salinity, temperature, depth, doing some trawling. Really great opportunities there to get in the water right away. So first semester, first science class, you'll be in the field. You can double major in aquarium science and biology. The difference between double majoring in biology rather than marine biology is that you would select less marine focused coursework is what I would say. Percentage of students that are employed after graduation, the most recent numbers that we have received from our career office, which was a poll of graduates, of about 150 graduates, 67 of whom responded, 97% of them were employed. Now, the next obvious question is, are they employed in their discipline? And we don't have that level of granularity. What I can say is a lot of our students coming out of our marine bio program are very competitive for graduate school, very competitive for technician type of job opportunities, nonprofit organizations, and so on. But the specific number beyond that, I'm sorry, I just don't have that information available. How often will we snorkel and or do we scuba dive? So what I can tell you is there's a scuba diving club through which you can get certified. A lot of our students do that. There's also a scientific research diving course that you can take on campus. As far as snorkeling goes, you live on a waterfront campus. Bring your snorkel and your mask, and you can get in the water whenever you want. But it depends on the class. So my marine phycology class, again, that's the seaweed biology class. I always tell students, make sure you bring your gear because we have great opportunities to get in the water. And you know, if you're coming to college in the ocean state and you have snorkeling gear, bring it with you. There's no shortage of places that you can get in the water and really explore the environment and start pursuing your curiosities in marine bio. All right, I'm going to hop back to the presentation here a little bit, and I'll keep the questions coming in, but those ones were particularly relevant to this focus on majors right now. And I got that first stat right there. Over 80% of our graduates had more than just a single major. Remember, that's not necessarily 2 majors, but it could be minors and other programming. 87% of our 2018 graduates participate in experiential learning activities like internships, community partnerships, research opportunities. And I think our department does a really great job at looking at interdisciplinary opportunities. So for example, one of our aquarium science scientists, excuse me, has partnered with a chemist. So they're looking at detecting cyanide in fish. This is a really, really cool project because cyanide fishing is a really effective way to collect fish, very valuable fish. Right, it works really well because the fish will recover from it. It makes them easier to catch. The problem is it damages the coral reef. It's really, really harmful to the coral reefs. And so my colleague, Dr. Andrew Ryan, has, in partnership with one of the chemists, Dr. Nancy Breen, and many, many students, have figured out some ways to detect cyanide in fish. So what this does is basically give them a way to police whether or not a fish was procured with very toxic cyanide poisoning. So this can hold the people who fish in that way accountable, or the whole aquarium trade, right? So that's one of the things that my colleague, Dr. Ryan, works on. He's built a whole database infrastructure to track shipments and is developing these novel chemical assays to figure out, you know, how long does it take for the fish to clear that cyanide? In other words, how much time do they have that they could still detect that that fish was harvested using a very environmentally harmful practice? So it gives a way, I mean, if you're interested in conservation, these are the kinds of projects that you can latch onto. And not just straight from biology, marine biology, you can approach it from chemistry. There's interesting collaborations between biology and engineering, and biology and physics as well. And physics is a relatively new program at the university, but we have several students who are combining physics minors with their biology as well. So really cool, interesting opportunities there. We have really great interdepartmental collaborations, as I was just describing in the natural sciences, but you can take it outside of there. You know, so it's just a couple of examples here. You know, do you want to produce documentary films that promote marine conservation? You could do that here. Are you a writer? Do you have a passion for nonfiction storytelling? We need people to tell the good stories of science, right, and communicate that. Are you concerned about social justice of human-induced climate change? There's opportunities to pursue that. I'm going to give you one example of this here. These are illustrations that were done by a former student by the name of Nick Bazzaio. He is an outstanding, fantastic illustrator. And what I will tell you is he brought his talent with him, but he honed it a little bit. We do have a biological illustration course. But these are illustrations that he made for the Audubon Society of Rhode Island, which has a collaboration with the university. Actually, our students maintain the aquarium facilities over there. And Nick and one other student collaborated on the production of these placards for that, for some of the displays over at this facility. Nick is somebody who took great advantage of opportunities here. So he was a research assistant. He worked with Dr. Collin on some of that jellyfish predator-prey video-based research that I mentioned earlier. He was an intern at the Marine Biological Laboratory. And as I said, he did these illustrations at the Rhode Island Audubon Society. He is an amazing, amazing talented illustrator. You can find him on Twitter if you want to see more of his work. It's outstanding. But he combined all of these things and pursued this program in science illustration after his time at Roger Williams University, and was admitted to one of the most prestigious graphic science illustration programs. After this, he then went on for a stint at the United States National Museum of Natural History. That's the Smithsonian with the big elephant in the center. You probably may have visited that in the past. So that was just a really great example of how somebody leveraged their marine bio in very innovative ways. We've also got several other unique programs in the marine sciences, including these semester-long programs in many, many different countries. We have a very dedicated program that works really well for marine biologists at the Biological Institute of Ocean Sciences in Bermuda, and also association with sea semester, so students can spend 6 weeks at sea, 6 weeks on land, but they also learn to sail as well. We've got short-term study abroad programs in Panama and Belize that alternate in odd and even winters. I teach one of those courses down in Panama, which is just, it is so much fun to be able to get to very different environments over a very short period of time, because Atlantic and Pacific environments are separated by very little distance. We enjoy, a nice community of scholars in the Department of Biology, Marine Biology, and Environmental Science. We have a weekly seminar series. There's some active student clubs, Marine Science Club, Biological Honors Society, which doesn't exclude anybody from their activities whatsoever. And collaborations with other programs in chemistry. You see this was an underwater pumpkin carving event with the Scuba Club, and the Foundation for International Medical Relief of Children often travels over spring break to do volunteer work in different countries as well. It's really important for us to know you as students in our programs, and so we hold annual events that in which we attempt to engage with our students to get to know them more than just as the people in our classrooms. As I mentioned a lot so far, there's really great research opportunities and lots of different ways to get involved with that. You can do it for credit, for volunteering, you can do a thesis. Sometimes you can get paid for it if you qualify for work study, or if your mentor has external funding, they can often pay you as an undergraduate assistant. So it's a good way to learn some more science, learn how science is done, and also be funded to do that. In those cases, it's commonly associated with travel to meetings as well. The work that you do in these kinds of opportunities is not, it's not demonstrative. It's not just, oh, this is how you do it. It is, we don't know the answer to this question, and we need to put our minds together to try to figure out a solution to this problem. So this is like real world. This is how science is done. We do science with you, and we rely on students to contribute to these projects. It's a really essential collaboration. As I said, we are active scholars. This is just a sampling of scientific meetings of various sorts. You can see they happen over a broad geographic range: Philadelphia, Las Vegas, Quebec, Hawaii, and so on. It's really exciting to be able to go to these meetings and to meet other scientists who you might be reading about in some of your courses and so on. And as I mentioned before, these often translate to peer-reviewed journal publications. This is the currency, the language of science, and our students are engaged in this. Now, it's not every single student. I don't mean to suggest that every single student is going to be walking out with a publication. It is a ton of work to do this. But you have access to this by enrolling in the marine biology programs at Roger Williams University. And that's access is what it comes down to. And access to dedicated faculty, access to world-class scientists, access to infrastructure. We've got really beautiful facilities that unfortunately I can't show you in their vivid, real life detail right now. But it's there, and that's what facilitates this work. So these are just a few examples everywhere where you saw yellow highlighting in these two slides. So I just went back. These are undergraduate students who are behind these publications in collaboration with their faculty mentors. So these aren't flukes. These are, this happens with some frequency. In fact, I just got word that one of my former students who's be graduating this year just got her first revisions back, and they were very well received. So it's an impressive accomplishment for sure. This slide just shows some recent awards from the National Science Foundation. This is just one of the funding agencies that that scientists at Roger Williams try to tap into to support work. But what's represented in here is close to, well, it's actually about $4 million worth of research, a bit more than that in this small sampling here. So active scientists, publishing, securing grant money, this translates to research opportunities for students. And as I said, that's really central. Our faculty, several of them highlighted here with their programs, and you can see two pieces or two sort of snapshots of our wet lab here. This is Dr. Levitt, one of our shellfish biologists who's actually retiring this year, and then Dr. Cody Sharp over here. And they're making the news, and so this is pretty exciting for all of us. We have a really active summer research program where we have somewhere between 30 and 50 students over the summer. Usually it's more like 45, 50, so the upper end of that range. Frequently housing is provided, and you get paid for that as well. So really great opportunities. And I want to emphasize that we don't have a marine station. We actually are a marine station. Our campus is our marine station. We are right on the water. And if you can follow my cursor here, this is the learning platform that's right. This is a sailing center. And then right up here, you can't really see it in the trees, is our Marine and Natural Sciences building. So you are literally a 2-minute walk from one of your field sites. Our boat can pull in right over here. So this is great for accessing the bay, for sampling, finding specimens for your seaweed biology class, for example, or just going out and checking out your environment with kayaks that you can check out from the rec center, or going snorkeling and so on. There's our research vessel called the Invincible Spirit. We can get an entire class on this, which has really changed the way that we deliver some of our introductory coursework now, which is really nice. Good opportunities for students to secure boat time as well. We've got a very active wet lab and a shellfish hatchery. You can see all these colored tubes. These are actually purchased from a beer making company, but they are great for producing algae, cultivating algae for feeding to our shellfish in the shellfish hatchery here. So lots of different research projects going on in here. And we also have the aquatic diagnostic laboratory where so much of the studies on marine invertebrate disease are undertaken. As I mentioned, we've got a lot of students moving on to a variety of different programs and graduate school opportunities. I think students that complete the marine biology program, and especially those who also engage in undergraduate research, have set themselves up really well for competitive graduate opportunities after Roger Williams. So just want to wrap up here and let you know that myself and my colleagues, scientists at Roger Williams University, are really eager to cultivate a new generation of curious, creative, enterprising, and resourceful thinkers who understand the problems of our day through rigorous and inspired coursework, and who leverage that experience to address interesting research questions in the lab, in the lecture, from the field, and I should add to this slide as well, from our homes more than ever now. We are really dedicated to this enterprise, and I really mean it when I say I love what I do. I've got the greatest set of colleagues who are so dedicated to student success. It is extraordinary, and I for one feel very fortunate to be a part of this. And I hope that some of what I've shared with you today intrigues you enough to give us really serious consideration, because we would love to work with you. And I'll open this up for questions, but I'll just put this up here, that you can follow the Roger Williams University Sciences on Instagram, or if you want some bad dad jokes every now and then that have to do with algae, you can check out my Twitter field at BeWiserGetAlgae in there. So I will, let's see if I can move this over so I can see our screen. I'm going to stop sharing the screen in a second, just so I can return to our shared view here. And I can see lots of questions here. I'm going to scroll through these. What type of study abroad options are there for marine biology? We've got a lot of students that go to James Cook University down in Australia. I've had former students that have participated in programs in New Zealand. I would say the most popular program for marine biology is the study abroad program at the yes, in Bermuda, the BIOS program. I'm flicking on the acronym right now. Bermuda, that's what the B stands for. In Bermuda, it's the Bermuda Institute for Ocean Sciences. You get a full semester of courses there, research. You go down dive certified, you come back with a research diving certification, and that is a skill that is really cool. That is very well received in certain graduate laboratories that are doing undergraduate work. So you get, you learn way more than just, it's not just diving, right? It's being able to be completely 100% distracted from your normal, like all of the gear of scuba diving. Gives you the skills to go do research underwater, and give you enough experience that all of the actual scuba diving, breathing essentials, like they're totally secondary. So it's a really great opportunity for students. But like I said, also there's the short-term study abroad programs. So we have 10 days in Panama that's got sandwiched between coursework on campus, but that is completed in the January intersession, and the program in Belize runs in a very similar way. So these are opportunities that they're alternatives to a full study abroad. The full study abroad programs, there's other offices you should check in to know more about those, but expenses for those are on par with expenses for a normal semester at Roger Williams University, plus additional, like your airfare would be additional expense, and your spending money and so on. The short-term programs, I know the Panama course runs somewhere between $3,000 and $4,000, so they aren't cheap, but you get a phenomenal experience in the water. In the case of the Panama course, you're in the water somewhere between 4 to 6 hours most days that we are in country on that. So let's see, there are opportunities to study abroad in Australia. Again, James Cook University tends to be a pretty popular one. Would double majoring in aquarium science and marine biology be a difficult thing to switch to? It wouldn't. There is a GPA minimum. There are 4 classes. It's an introductory chemistry class, a introduction to marine biology class, an oceanography class, and a pre-calculus class. You have to have an average GPA across those 4 courses of 2.5. And then, you qualify to enter into that program. Some students don't do the major. A lot of students will do the minor, and there's no GPA requirements to do the minor. So there's good opportunity to take advantage of that very hands-on, very applied coursework that I think positions students very well to engage in field studies for aquaculture, as well as laboratory-based studies. So again, we've got outstanding facilities for both of these kinds of programs. If you do C semester, can you also study abroad? No, you could. This is where working with your advisor becomes very important, because you want to make sure that you fulfill all of your requirements in your 4 years. Our goal is for you to complete everything in 4 years. If you were not committed to that, you could probably do all kinds of study abroad. I actually have a student right now who's going to take 1 extra semester, but he's looking at taking his 4th study abroad experience in the coming year. So that's rare. I've rarely seen that. but I definitely have seen many cases where students will take advantage of multiple opportunities like that. Internship opportunities at nearby aquaria. So our nearby aquaria include the New England Aquarium, which there is some collaboration with them as well. Our aquaculture and aquarium science specialist, Dr. Ryan, actually has a joint appointment at the New England Aquarium and Roger Williams University. So there's very active ongoing collaborations there, and there is an internship class that we have for students who do an internship up at the New England Aquarium. And I've had lots of students who have undertaken that or pursued that internship. Some of our former students have then gone on and secured jobs there. The head of the education department right now, Megan Elizabeth Foster, she's a former Roger Williams University student, also participated in research, also participated in a study abroad course, right? So these these many opportunities have successful endpoints for a lot of students. The other local aquarium is the Mystic Aquarium in Connecticut, and we have had a fair few students who have secured internship opportunities there. Again, I think the coursework that we offer positions students particularly well at these kinds of institutions. So let's see. Can you do the study abroad program in Bermuda only if you're a marine biology major? No, you could. There's nothing that would restrict you. The only thing I emphasize is that it is particularly strategic for marine biology majors because the courses that you take are somewhat limited, right? So you would take a tropical marine ecology course, you take tropical marine invertebrate zoology, you take coral reef ecology, tropical marine invertebrate zoology, you do a research project, and scientific diving. So those are the only courses that you take. All of those would apply to the biology major with the exception of the research diving. I don't believe that would fulfill program requirements there. So you just working with your advisor, you need to look at how that will play out over the course of your 4 years. Do all coursework in the research laboratory or are they separate around campus? So most of our research opportunities, our research spaces are focused in the Marine and Natural Sciences building. That's where the wet lab was. There's a dry lab there. The shellfish hatchery is there. The aquatic animal diagnostic laboratory is there. And then there's smaller research spaces in there. So I have a small research space that is the seaweed biodiversity lab. These are spaces that could be configured to do any number of different kinds of research projects. They're not specialized in the way that the wet lab or the shellfish hatchery or the aquatic animal diagnostic laboratory are. But all faculty are engaged in research. Some of them, the nature of the research doesn't require laboratory space, or their laboratory space is at the Woods Hole Oceanographic, the Marine Biological Laboratory, for instance. So through collaboration, they're working in different spaces. That actually works out pretty well for students because it's an opportunity for students to get out of Roger Williams University and look at the research environment in a different institution. So that is pretty cool where that happens. But there's a lot of it's happening right there in the building where most of our offices are. And there's ways to integrate. So I would say most of the faculty are dedicated to bringing in research opportunities in the classroom. So I've done DNA-based sequencing studies of marine algae. So my research background is in seaweed biodiversity, and I ask very simple questions like, what is this species? How do I know what it is? What are the features that define it as, genus A, species B? And I can do all of that out of my laboratory, and I can do all of that in my teaching laboratory. So I bring that research into my teaching, and many of my colleagues do the same. And so there's sort of a balance between doing that kind of research in the lab as part of the teaching lab, as well as also doing some demonstration type of laboratory experiences. So showing the research projects, the research project, and sort of practicing techniques, learning skills, how to analyze data, and so on. Let's see, is there any specific computers or other technology devices that marine biology students should have? We recommend a laptop computer that works for you. Whatever your favorite laptop computer will serve you very well. Where specialized equipment is needed, mostly they're going to come with their own kind of very specific software requirements, and so students have access to that with training with your faculty advisor or other students. So I would say, beyond a basic laptop computer that you're going to use in all of your classes, there's nothing more specialized. I will also say that it would be entirely possible to navigate this curriculum by using university resources and computers. So we have several different computer laboratories where you can execute the work of your classes in that space. Let's see, is it possible to double major in marine biology and environmental science? Yes, it is. Could I double major in marine biology and engineering? You could. I will say that's very curriculum intensive. I would be a little bit surprised if you could double major without taking a little extra time. The engineering curriculum is pretty tight. In other words, there's not a whole lot of flexibility. Some students do it, but there's not a whole lot of flexibility in terms of course selection on the engineering side. I mean, I think the marine bio curriculum is a little bit more flexible. I would say, if you're looking at that, you definitely want to think very carefully about the timing of that. And so that's a great question to talk to somebody in engineering about as well. And they're two time-intensive majors, and so one of the things that's really important to understand about the marine biology curriculum is that any curriculum in the natural sciences is that you've got laboratory courses. Those laboratory courses will have 3 hours of lecture per week and 3 hours of lab per week. So whereas let's say a communication major might have 5 classes and 15 credit hours, the science major is going to have 5 classes, but 2 of those probably will be laboratory classes, maybe even 3 of them. But if you have 5 classes with 2 labs, that's like taking 7 classes. And so it's more time in your schedule that you're actually in the classroom, and so more time in your week, which makes like trying to take all of those engineering courses and all of those bio courses plus all of the labs, it just takes a little bit more careful planning in there. I don't want to say it's not possible, but you have to be a little more on top of it. If you come in with a lot of advanced placement credits, that certainly helps for sure. Why can't you double major in marine biology and biology? Because there's too much overlap. So the basics of our biology program and the basics of our marine biology program are very similar, right? So you have introductory courses that are very similar that are the same between those two. Marine biology has an oceanography and an intro to marine biology foundational requirement that biology does not. But you also take genetics. You take Gen Chem 1 and 2, you take Calculus 1 and 2, or math through pre-calc. You take a stats class. All of that is the same between those two programs. So it's hard to differentiate those until you start taking the marine biology specific courses. But because there's so much overlap, it's not like you're really getting that much more specialization if you got the biology major. And what I'll tell you in the end is, I mean, I'm a marine biologist. First and foremost, I say I'm a marine biologist and I'm a phycologist. I study seaweed, I study algae. It doesn't matter though, right? I mean, if you graduate with a biology major or marine biology major, I don't think you are, that one is necessarily better than the other. Marine biology is a little bit more specialized with the coursework, right? Biology is wide open. And you could certainly do a marine influenced biology major by selecting some of the marine biology coursework. And you could go very focused, you could be very molecular based as a marine biologist as well. So if your interest is that, I'm interested in sort of really wide ranging things, not just marine biology, you'll be able to cover a very wide breadth through either of those majors. And again, the opportunity to meet with an academic advisor every single semester is a really important aspect of helping you to navigate that and figure out what is the most strategic set of course that I can take to get to some end goal that's going to position me well for success after Roger Williams University. And every semester, you're actually required to meet with your academic advisor, and they are your scientists. They are your professors. It's not, we don't, I mean, there is an academic advising office, but all students are assigned to an academic advisor in their discipline. So that's a really, it's a great benefit to students because it helps to connect you, right? So I said, framed everything as access. And this is a way to help you, sort of connect to those different access points. Do we need to provide our own equipment such as waders or other water gear? We have some. I would say scuba gear, snorkeling gear, yes. There's a lot of waders on hand, so not necessarily. But if you are committed, the investment in your own equipment because of reliability, right, rather than having shared use, is certainly welcomed, encouraged where it's possible to do it. But where it's not, yes, there is shared equipment. Would I recommend getting scuba certified before taking certain classes? It's not a specific recommendation that I have for no coursework at the university requires you to know how to scuba dive. If that's something you want to pursue, I encourage it because it's wicked fun, because it can help you access marine environments in the vicinity of the university, in your home territories and so on. And that gives you a way to pursue your curiosity, to be selfish with your learning, to bring your own experience to bear on the academic experience, and have that shared experience with your professors. So do it if it's possible, because it'll change the way that you look at marine science, right? You'll have that firsthand experience. The only exception to that is that if you study abroad in Bermuda, you do need to be dive certified. They want you to have your basic open water certification before you go down. And now that I've said that, if there was something that prevented you from scuba diving, say health-wise, that you don't qualify for scuba diving, the university absolutely would be committed to figuring out how to make the abroad experience in that environment a workable solution for you, okay? It's a requirement of the university to make accommodations like that. Are students going to have to purchase gear for scuba diving themselves? The way the scientific diving class goes, I don't believe you have to have all of your own gear. I think basic mask, fins, snorkel. I think the other gear, your buoyancy compensator, your tank regulators, I think are provided in that, but I'm not 100% sure on that. Does Roger Williams University accept AP Stats, AP Environmental, and AP Bio credits? So if you score a 4 or a 5 on the AP Bio exam or Environmental Science exam, I believe you get exempted from, if you get a 4, you're exempted from 1 introductory class. If you get a 5, you're exempted from 2 introductory classes. And stats, I think, will get you through the, I have to check on that one, but I think it will exempt you from one of our statistics class, our basic statistics class. Now, just a quick word about AP courses. I wish you the best of success on those, because they can really give you a little more time at the university, and time is fantastic because it allows you to take a course in maybe a different discipline. Maybe you're wondering, is film studies for me, because I really want to bring film to my marine biology, or vice versa. Having that flexibility is fantastic, but also it removes you from that first year experience with your students, where some of the skills-based coursework is taken, which your professors in upper level classes sort of rely on you to have. So you miss a little bit of that shared experience. So what I'm saying is, absolutely, if you have access to that and you can perform well on that, do it. But if you don't, it's not the end of the world. And even in some cases where students have earned a 4 or 5 on that exam, they actually choose not to forego those introductory courses for the reasons that I just explained. AP Chem and AP Calc, yep, absolutely. And actually, if you can access the university catalog online, and there's a section in there that describes exactly what the list of scores are for each of these exams and what they would exempt you from, or how it would be credited towards your program requirements. So if you just search for the RWU catalog with Google, that'll come right up, and you can search on the string AP, what would be AP exam or something like that, or actually just search for advanced placement, and you'll get to a table and you'll see the full list of courses that are available. Let's see. Do IB, so that's the International Baccalaureate. I don't know what HLs are, but in that same table in the catalog, they're all described. Okay, so the AP and the IB coursework there. Oh, great question, Payson. I hadn't even heard that AP courses were open book this year. I don't know whether the question was, will the AP courses still be accepted? That is a fantastic question for which I do not have a good answer. My sense is yes, that they would be accepted. Do not quote me on that. But I think, Zaria, do you have insight on that?
So I know the College Board, company is going to be, I know they're redesigning the AP exam and everything. So they're obviously going to be communicating with the universities, but know that we're going to be very, accommodating to students, because clearly this is, no one's choice. So, and we do know you're working hard in those AP classes. So just kind of stay up on that, but know that it should be a go ahead though. If you do well on them, then you'll probably get the likely credit. Okay, so just kind of leave more in the positive direction, but we're definitely learning to be more flexible. Okay.
Great, thank you for that. I don't know what ECE environmental credits are, so I cannot address exactly how they might be applied to the program.
We take, it's like another class students can gain college credit from. So I might take an ECE. So yeah, we'll take the environmental credits. We take classes, the majority of them.
All right, great. And so what I would say, I know a lot of you might be in any variety of classes like this, the AP, or maybe you have, you're taking a college credit course, through your high school. That kind of coursework, it translates pretty seamlessly and offers a lot of flexibility. So, try to stay focused on those, try to do your good work there, and see those to a successful conclusion. Basically, even 4 credits brings in flexibility to your program. We've had students that come in with 4 credits, 8 credits. It just gives a little more flexibility. And again, having said that, the majority of our students come in without other credits into the marine biology, environmental science programs. And the program is structured to get you through it in 8 semesters, averaging 15 credits per semester. So it's entirely tenable. So we're here for you. Are there any questions that I didn't address from the chat? I think we kind of hit all of them. I don't think I skipped any.
I think we just got one more, I think, popped up.
Oh, great. Would double majoring in aquarium science and biology be a good alternative? Oh, it's entirely feasible. There's nothing, I would say double majoring in anything is great. I don't know if you mean, is it a good alternative to marine biology, or do you mean marine biology paired with aquaculture and aquarium science? The aquaculture and aquarium science, the marine bio and aquaculture and aquarium science? Yeah. It works. It works totally fine. It could give you, at some level, it might depend on what your interest is. So if you're interested in, we had a research, our Dr. Levitt was our, Dr. Dale Levitt is a shellfish biologist and outreach specialist. And he was doing some work looking at probiotics, the introduction of probiotics in, so bacterial-based foods or supplements to foods for shellfish. Would this improve the quality of the shellfish product? You know, if you're interested in that kind of project, you might take a microbiology course. You might take some chemistry alternatives. So I could see somebody taking a couple of courses that a lot of marine bio students might not take. Or maybe you're looking at how to do gene editing in shellfish. And so you work with our cell biologist, Dr. Chris Bertner, to find some ways that you could improve the metabolism of shellfish in our hatchery system. I could see exploring more on the biology side, but applying that to aquaculture and aquarium science. So to some extent, it depends. That's where sitting down with your advisor, who's one of the scientists on staff, and saying, you know, look, this is kind of what I'm interested in, and I'm not sure that taking this course on seaweed biology or biology of plankton is really relevant. Maybe instead of that course, maybe I take the cell biology course and I take the virology course and you know, another you know, specialized course in upper level biology. That would be totally feasible. And it is not the kind of thing that you need to decide on day one. You know, and aquaculture and aquarium science is not a day one major anyway. That's get into the program, biology, marine biology, environmental science, whatever it is. You can get there through any of our programs. But come on in, see what you like, work with your advisor, and you can change your pathway along the way. I believe the statistics, sorry, maybe you can back me up on this, 75% of students change their major at least once over their undergraduate career. Is that conservative?
Yes, that's across the United States. So it's definitely a known fact that you could change your mind.
Yeah, and it's, you know, I've had lots of students that I've advised into other majors. I am not at all like trying to convince people to be scientists. I want to connect them with the best resources for them. And if you come in and you decide, I don't know if biology is where I want to be, I don't know if marine biology is what I want to be, but you know, I still like science. We've got a program for that. You can finish your minor instead of a major, minor in biology and marine biology, environmental science, and maybe you go into professional writing studies or journalism or film studies. Maybe you major there, but you leverage that interest that you already have. You kindle that interest by completing the minor in these disciplines, you know, and you walk away with something that you are really genuinely passionate about. I think that's one of the really cool things that students can do at Roger Williams University is you can pair your curriculum really strategically and do some really innovative things, and you get to drive it. And in fact, if you really want, you can develop your own major. It's called an independent, individualized major. And in consultation with a faculty member, you can kind of create your own major. You have to have, you know, your coursework carefully prepared, and you have to show why that particular set of classes is going to be better than one of our well-defined curriculum programs. But several students have done it. One student developed it in a science communication, which was very productive. Had some other students who have defined programs that are more writing, like scientific writing and so on. So lots of different ways that could shape up depending upon your own interests. It takes some, you know, dedication on your part to find the advisor who will help you to craft that. It's definitely something you craft in collaboration. But, you know, really outstanding opportunity for you to get exactly what you want to get. And, you know, whether you come to Roger Williams or not, my piece of advice to you is, well, I have two pieces of advice. One is be selfish with your learning prioritize your learning. You are paying a lot of money for this program. Wherever you go, you're paying a lot of money, or somebody's paying a lot of money on your behalf. Get all the value you can out of it. Take advantage of those opportunities, because you're buying access. You're not buying a degree. What can I get at this university? Can I get research? Can I get study abroad? Can I get a minor or additional minors to complement my major? If I decide that I need or want to change my mind, is there another outlet there? Those are all yeses for what I've explained from our program today. And the second piece of advice that I have for you, regardless of where you go, is establish a good relationship with somebody in your program, with one of the faculty members in the program. Being in front of the right person, I think, is so useful. And at Roger Williams University and in our department, we try to get you in front of us right away. We love to sit down and talk with you to figure out what's going to be the best pathway for you. And out of 3,500-ish undergraduate students, every student, almost every single student, has a unique pathway through the program, right? They're all fulfilling the same requirements, but every student has a unique pathway, and that pathway is important and specific to that student. And it's like, that's like, you can go after stuff that is important for you in there. And there's the challenge at Roger Williams, I believe, is that there's so many varied opportunities, and not just in the sciences, but that's what I'm speaking to right now. You know, you're going to have to pick. There's relatively few students can really do it all, but some of them do. Some of them double major, do research, do study abroad, get their scientific diving, and so on. So, you know, I wouldn't rule anything out. There's great opportunity there, and that's certainly the challenge for you. Let's see. Any other questions that you have for me? Does anybody wonder how you can have a job studying seaweed? A few of you, I see some nodding heads. Yeah, I definitely lead this cherished and life that I get to explore seaweed biodiversity. But you know what? If nobody's studying seaweed biodiversity, we might miss out on that opportunity to realize that there's a species that produces a compound that helps us to control bacteria in hospital infections, for example. That's not what I study. I study the seaweeds, right? But we can explore these organisms for their applications, and it's really cool. What else can I offer you? I will say, if you realize, oh, I have a question, I wish I would have asked it, my email address can be found online. I like to say it's good advice, bwiser@rwu.edu. I'm not in my office right now, so email is probably the best way to get a hold of me. But if you do call that number and leave a message, it will get forwarded to my email address. But I will do my best to get back in touch with you. And if it's easier to talk, I'll try to set up a time. We could either meet like this, or we could figure out a good time to talk, because I would way rather actually talk to people than to be back and forth in email. And anybody want to raise their hand about how much they love email in social distancing when you've got like 8 million emails a day? It's a little crazy, right? So I have 3 kids in 10th grade, 7th grade, and 4th grade, and even 4th grade getting his fair share of email. So it's a little crazy right now. What else? What other questions do you have? I'd love to address them, or curiosities.
And if anything does come up, you know, later on, obviously you can contact Professor Weiser, but then also know that we even have a marine biology and environmental science Q&A. I forget which day it is, but I know it's one of the days that we have coming up in these 2 weeks of presentations. So check out that list again on the website, because there's also a Q&A where it's just like question and answer. So
yeah, and I expect to be there for those
right.
Q&As. So for both of them that are planned right now, along with some other colleagues.
Right. So that's always another option. Okay.
Yes. Well, I wish all of you very, very good luck, very good health to you and to your families. Stay committed to your online learning as you know where you can, and I'm really hopeful that we'll get over this sooner rather than later. But when the time is right is when it's going to be right, and I want to congratulate you on navigating a college search process and your acceptance at Roger Williams University. Great job to you guys, and I hope to be working with you in the near future.
Thank you very much for your presentation. Great job.
Right.
Congratulations, everyone, and stay healthy. All right.
All right. Take care, everybody.